really it's not that bad. How do we set up the helicopter? So again, there's a few things we spoke about a minute ago when we spoke about um, engines. We need fuel, we need ignition, we need oxygen. Okay, so exactly the same as your car engine. We need all those sort of things. Okay, we'll talk about starting up in just a second. If I put the battery on now, when I was flying a Cessna yesterday, I weren't able to start it up because I drew the battery down. So we'll talk a little bit about all of these dials. Okay, this here is your angle of bank indicator. Basically, as we turn left and right, this dial will move, and it basically sets out our turn coordination and our rate of bank. We've got our clock. It functions, so you can set your time. It should have a stopwatch function. Let's have a look. You can interact with it. Again, these little details that they've gone into are brilliant. Your day and night modes and your system lights. Okay, we're not going to worry too much about that. Okay, these are the important ones. Here you have NR. Okay, N is a figure of how fast something's going. Okay, so it's speed. The R is rotor. Okay, so this is our rotor speed. Most conventional gauges now have the amber, yellow, and green zones. Obviously, what we aim to do is we would keep that NR in the green. It does that efficiently by using a FADEC system. This aircraft will have one. It's basically a computer that manages throttle. Okay, it manages fuel and all the elements required for keeping the rotors turning at 100% RPM. What if they're not running at 100% RPM? I can show you that later. Essentially, what will happen is you will crash and burn. Okay, so as soon as it drops below around 93 to 94% NR, you're going to have a reduction in lift. You're going to have issues. If you don't sort it quite quickly and you drop below 90 to 92, and we'll talk about why those figures are important shortly, you're going to fall out the sky. Okay, the aircraft can no longer sustain flight. You may have heard of a term called an auto rotation before. Now, I have tried it in this aircraft before and it didn't work, where I basically turned the engine off and I tried to land the thing. And the way you do that basically is you need to keep the airflow flying or going through the head. So to do that, nose down, get some forward speed going. It just dropped me out of the sky. So it wasn't really designed. The sim hasn't been designed well enough to actually cope with that element of it. I don't think I've tried it on this helicopter. I think I tried it in a Cabri. It may work on here. We can try it a bit later on. We can see. Your airspeed indicator is here. This is your airspeed in knots, with this aircraft having a maximum of just under 156 knots. Okay, you'll see the checkered flag here. You don't really want to be flying over that. Okay, that's in your. You don't really want to go past that. Okay, so we'll try and keep it around 120 knots when we're flying. This has got radar altitude. We spoke about that a minute ago, and this is accurate height above ground. And you can see here that you can set a bug. Now, in a lot of aircraft, what this will do is this will signal potentially a audio signal. It will definitely give you an audio signal, and sometimes on some aircraft it will give you a light and a warning as well. On here, when I've tried to use it and I've tried to set in that bug, it's not done anything. Okay. And that's basically our decision height. We want to know if we're going to go beneath that. So when I do the hoist missions I do quite regularly, what I would do is I would set this at 50 feet. And because that's the optimum height for the winch in on this, if it buzzed at me, I know that I'm dropping below 50 feet. Okay. And then you've got a test function here, which we'll use shortly. This here compass dial, you've probably seen it in quite a few of your helicopters now. Exactly the same. Enables you to set your course and your heading. Course and heading, two completely separate things. Two completely separate things. That's a different lesson in itself. That's going to be for navigation. We'll talk about that and we'll visit that another time. You've then got your attitude indicator here. Okay, so this will give you your pitch, roll, and pitch and roll information and your angle of bank. Okay, so we'll see what that looks like when we spool up. You've got your altitude indicator here. Okay, so you've got your hundreds of feet, which is the outside, and then your thousands of feet, which would be your small hand here. So if we had that small hand on 1,000 with the big hand, the small hand on 1 with the big hand on 1, we are flying at 1100 feet. Now, what's really important about this is your barometric altitude. We'll look at that when we start the aircraft shortly, okay? But we need to know our height above ground. It's measured in inches of mercury, so that's the old system. I think I don't know if Americans still use it, but we now use hectopascals. 29 and 902 would equate to 1013.25 hectares or hectopascals. Okay, but the game at the moment, I haven't found out a way to change it to hectopascals. So sometimes if you get your QNH given by your air traffic controller in hectopascals, you'll have to Google it in order to set this straight and set it right. And this is done by your static vents that I've shown you outside. And the last thing you've got is your vertical speed indicator, and this will give you your rate of climb, so how fast you're going up, and your rate of descent, how fast you're falling out of the sky in foot per minute. Okay, you have to bear in mind that if you start descending too fast, you're going to create the turbulent air, and you can enter vortex ring state, and that's basically where you've started going through really turbulent air, often of your own making. Okay, and you try and keep your vertical speed really just above minus 300 feet per minute. You don't want to go much further than that. Just bearing in mind, I'm not a pilot, so that's all the information actually related to flying these things. I'm sure that if you actually got an Airbus pilot in here, they'll be like, hang on a minute, I regularly fly, descend at 1,000 foot per minute. So just bear that in mind. And then here you got your standby compass, okay, and that's just basically completely independent and away from any electrical interference. So quite often you'll see it up here. In some aircraft you'll see it, I've seen them up here on a stanchion, particularly if you've got pitot tubes or you've got window heaters where you've got a large current coming through. And obviously this here is a great stanchion here for cables and electrical cables, and obviously Teleflex, Bowden cables, whatever they're using. So they try and keep it away from interference. You then get your location transmitter over here, and that's pretty much it for all the dials. Down here you've got your radios, and you've obviously got all your systems in here. We'll talk about those as we set the aircraft up, which is what we shall do now. Let's have a go. So again, this isn't a tutorial on how to set the aircraft up to fly. My biggest piece of advice to anyone whenever I'm on a stream or whether I'm on Facebook is to go through these checklists, okay, because they seem like quite a lot. Okay, now all this is mainly outside. They seem like quite a lot, but actually you can go through it really quickly. These are your external checks, and then you'll do all your internal checks here. Okay, but you do go through them really, really quickly. Turnaround check, for anyone that's not too sure what that is. So once your aircraft's serviced, you can have what's called turnaround servicing. You don't need to know that. It's just another element of what ground crew can do. And then you've got your before engine starting checklist. So go through it all, and if you're not sure where everything is, these features here, where you can press the little eyeballs, are fantastic. Tells you how to start the engine, what happens when you do start the engine, how you run up the engines, okay, so that's quite important as well, what to do in flight, all different phases, okay, and I'm sure there will be a place where you can print all these off and have them for you. Okay, I've got my iPad sat next to my computer that I use quite regularly as an e-board. So we're going to very, very quickly start this aircraft up. Okay, so for that we're going to have the battery turned on. This applies DC power to the aircraft. And one of the things I don't like about this is if you have a look now, my attitude indicator is beginning to come alive. Or is it not? Well, it might be different on this. Okay, but on a Cessna, on the 172, I think it's different on this, which is actually right, because that is three-phase AC. On a Cessna, I know that it was the attitude indicator alive. Okay, AC, battery creates DC, it's never going to work. Unless you have a standby, like an emergency system. You can get those. You can get rectifiers, which are DC, 28 volts DC driven. The generator, okay, we will turn that on now because there is protection circuits. However, the generator won't come online until your engines and rotors are spinning and operating at a certain speed. Again, that's all about monitoring for over frequency, under frequency, and all that sort of stuff. Anti-collision lights. Okay, these are the lights on the side and rear of the aircraft. And then you've got your horn. Now, if I put the horn on, you'll hear that warning tone. We'll leave it off for a minute, and I'll talk about that, and I'll show you why shortly. And you've got your avionics. Avionics will then turn on all your GPS and your radios and everything like that. Now, because I don't want to kill this battery, I'm going to quickly start the aircraft up. So to do that, we make sure that we are in idle. If we set it in flight, we're going to put too much fuel into it too quickly. We're going to make sure that our fuel shutoff valve is open, rotor brake is on, and we're going to press the master start button. We've checked fuel, we've got 49% fuel. Close that up, and then what we're watching is down here on these gauges. We're going to watch now the N1, so compressor speed is speeding up 20%. My rotors are going to want to spin, so I'm going to take the rotor brake off. You'll see the rotors come around in just a second. As the engine speeds up, where are they? Come on, boys. There it is. As the engine wants to speed up, we can see it happening here. You've got your temperature, so your power turbine inlet temperature. So this is the temperature at the turbine. Again, that's one thing we don't want to fry. You've got your torque. Now, this is a little bit like, again, I don't know the setting of this aircraft. You see the generators come online now because the attitude indicators come alive and the generator caution has come out. Yeah, your torque is at 90. I don't know how realistic that is for this aircraft, but I mean, sometimes see it when I start these aircraft up over 100. You're not going to be smashing in 100% torque. And then you've got your outside air temperature, and you can see here now that we're self-sustaining, which means that the starting system has cut out the burners of the starting nozzles and burners and igniter plugs and everything has stopped banging off. We're now nice and settled, okay? Now if you have a look here, we're at 73% RPM. Now just to show you what happens when I pull the collective, so I try and pull power, it wants to take off, but it's not going to. The reason for that is you have not got enough speed. You'll see that rotor RPM dropping. It just wants to spin. You haven't got enough speed to sustain safe flight. Okay? If I drop that collective again, you see the RPM just starts to increase again. Okay? So if you are getting it up and started here, and you're wondering why you're crashing and you're dying and your aircraft's going into 1,000 pieces, you've still got another step. Okay, we have to be flying at 100% RPM. So to do that, we come down to our throttle and we put it to flight. Watch what happens at flight. I'm going to turn the horn on. Now that, when we get to 92%, you'll see that shortly. Wait till we get to 92. You can see the RPMs down the bottom left. You can see your rotor RPM here. It cuts off. Okay, so that is quite safe for flight. Okay, and you'll see now the N1's dropped. And again, I don't know how realistic this is. I've never flown in an Airbus helicopter. I've never worked on one, so I'm not quite sure. However, that is, it seems quite drastic that they'd fluctuate like that. And with that, we're ready for flight now. You'll see here that we've got a couple of cautions. We've got the generator and battery. Those will basically will go away as soon as we start to launch. And you've got pitot. Okay, so pitot, as we said before, is your pitot probe. Where are we? Can you see it? Which is here. Okay. Now, what we have on there is a system to ensure that it's kept warm and doesn't freeze over. Because if it freezes over, that airspeed indicator here is not going to function. So, because I don't like having any warnings or cautions, I'm going to turn the pitot tube on, and we'll leave it on. Okay. The other things we could have done before we started the aircraft are your warning light test. I'm going to do that now to show you. And we do a fire test, and that's the warning. Okay, and then you've got all the other little switches here. Floats. I think that in this aircraft, if it's got a float switch, I'm going to assume that it's fitted with flotation bags. So if it lands on the water, salt water run into the actuators within there and set off the bags. Because we're going to fly over the sea, we'll turn them on. And then you've got all of the switches here, COM ones, nav ones, muting of the 100-foot mute, etc. Like that. And then you've got your